Hello students. Today we're going to expand on our vocabulary with segments and talk about the segment addition postulate. So to start off, I'm going to create two segments. So let's call this segment AB, and let's make another segment that's exactly the same as it, but just in a different spot. So to review the notation, we would say that this shape right here is segment AB, and this shape right here is segment CD. And let's say, for the sake of argument, that both of these segments are 5 centimeters long. So, to expand upon our vocabulary a little bit, I've got segment AB and segment CD, and one of the mistakes that people make is saying that these two segments are equal. The equal symbol, like that, is specifically reserved for numbers. So that segment isn't a number, that segment is a figure, it's a picture. So if I'm going to use the equal sign, I have to be comparing two numbers. That's where this notation comes in. If I write AB by itself, with no line on top of it like that, that means the distance from A to B. So if the segment AB and the segment CD are both 5 centimeters, I can say the distance from A to B is equal to the distance from C to D. Again, this sign right here, this is equal. Anytime we use equal, that means that we're talking about numbers. But what if I want to say the pictures themselves are the same? Now, AB and CD are two different pictures, but they're identical pictures. So we have another symbol here. It's an equal sign with a little curly on top of it, and that sign right there means congruent. Congruent is like equals, but for pictures, for figures. So what I'm saying here is that the segment AB, with the line over it like that, is congruent to the segment CD. AB is not the same as CD. They are not the same picture. They're two different pictures that are identical. That's what congruent means here. Now this brings us to our first postulate. Postulate is just a fancy way of saying it's a rule, but this is the segment addition postulate. So for this example, I want you to think of a ruler. So let's make a segment here. We'll say this is segment AB, and pretend that it's a ruler. That means that this would be 12 inches. Now what if I took that ruler and I broke it into two pieces? So let's call that point C. I'm going to call this point C as well, because I'm just separating them a little bit. So imagine I broke it at point C. Now I have two segments, and I pull them apart. Well, I don't know where I broke it, but what I do know is that if I take AC and add it to CB, it will add up to the original piece. So no matter how I broke it into two pieces, if I add those two pieces back together, I will still get the full 12 inches. And that, in a nutshell, is the segment addition postulate. If I have a little piece plus a little piece, it'll add up to the big piece. So let's make that formal, the segment addition postulate is, let me draw a segment here, A, B, C, like that. If I have a segment and there is a point in the middle of it, then I have a big segment and I have small segment and another small segment. I'll say smallest. Informally, it would be the small piece plus the smallest piece is equal to the big piece. Formally writing this out for geometry, we would say AB plus BC is equal to AC. Okay, let's give an example of how this would be used. Let's start simple. We'll say that I have a segment here, and we'll say this is A, B, C, and this piece is 7 units long, and this piece is 4 units long. So the question is, how big is AC? Now you may get the feeling right here, I could just do this in my head. I want you to go through all of the steps here because part of geometry is being able to clearly communicate your work. And the segment addition postulate is a very simple rule to use for practice for this because the rules that you're going to get later on are more complicated. So it's good to build this habit of showing all your work early on. So the question is, what is AC? Well, I would say AC is equal to AB plus BC because of the segment addition postulate. And show your work just like this. Write the reason down next to each statement. Now, my next step, I would say AC is equal to, well, I know what AB is right here. I know that AB is 7, plus I know that BC is 4. And for that one, I'm going to write, my reason is, that's called substitution. That's where I take one thing and swap it out for something that's equal. And then I can say AC is equal to 11. And for that one, I'm just going to call that algebra. If we wanted to get nitpicky, we could say that was combining like terms, but for right now, algebra will suffice. Let's do another one. Let's say I have another segment, DEF. And this time, let's say that I know that DE is 10, but DF is 21. And I would ask here, what is EF? Well, just like last time, I would say DE plus EF is equal to, DF, because of the segment addition postulate. Just like last time, I'm going to do some substitution. DE is 10. I don't know what EF is, so I'm going to leave that there. That is equal to DF is 21. The reason for that is substitution. Now, if I want EF by itself, I can just subtract 10 on both sides, and I'll get EF is equal to 11. And again, when I'm doing math like that, I can say that my reasoning is algebra.